students, welcome to Sunil's tutorial. I'm Sunil Nirvani and today we'll be doing this chapter called as alcohols. That's your hydroxy compounds. We are going to see chemical properties today. We are doing chemical properties of alcohols. Let's see this first. Let's see action of active metals. Now, what happens when methyl alcohol reacts with sodium metal? Methyl alcohol with sodium metal. What happens when methyl alcohol reacts with sodium metal? Now, methyl alcohol CH3OH, methyl, one carbon atom, alcohol OH reacts with sodium metal. This is your Watts reaction, right? So you will have sodium metal, two atoms of sodium metal plus methyl alcohol again, right? This will give you hydrogen gas plus CH3ONA. This is two molecules of CH3ONA, right? This is methyl alcohol reacts with sodium metal. This is methyl alcohol and this is sodium methoxide. Fine. Next, let's see a similar reaction now. Let's see the reaction of ethyl alcohol with ethyl alcohol with sodium metal, right? Ethyl alcohol CH3CH2, ethyl, two carbon atoms, alcohol OH, you are taking two atoms of that, reacting it with two atoms of sodium, will give you hydrogen gas, will give you two molecules of CH3CH2ONA, right? This is ethyl alcohol and this is sodium ethoxide, right? Next, let's see another reaction of this kind. What happens when propyl alcohol with sodium metal, right? Propyl, three carbon atoms, CH3, CH2, CH2OH, two molecules of propyl alcohol react with two atoms of sodium metal, right? In which case you will get hydrogen gas plus two molecules of CH3, CH2ONA. This is sodium propoxide. This is propyl alcohol. This is your action of active metals, right? Next, let us see the reaction with hydrogen halide. Second reaction with hydrogen halide. Let's see the reaction with hydrogen halide. What happens when ethyl alcohol reacts with hydrochloric acid? Ethyl alcohol with hydrochloric acid. Ethyl alcohol CH3CH2OH reacts with hydrochloric acid in the presence of zinc chloride anhydrous, right? Here you have hydrochloric acid, that means you will have dehydration reaction taking place. Water molecule will come out, right? If water comes out, that means H and O goes out, right? So Cl will substitute the hydroxyl group, so you will get CH3 CH2Cl, right? This is ethyl alcohol and this is ethyl chloride. Right? Next, let's see another reaction of this kind. What happens when isopropyl alcohol, with isopropyl alcohol with hydrochloric acid, right? Propyl, 3 carbon atoms, iso, that means I should have 1 carbon atom in the branch, alcohol, OH, CH3, CH3, 3 bonds, so CH. Isopropyl alcohol reacts with hydrochloric acid in the presence of zinc chloride anhydrous. Right? Same, you would have dehydration reaction taking place, that means water molecule is out, OH reacts with H. The OH group is going to be substituted by chlorine, so you are going to get CH3, CH, CH3, Cl, right? This is isopropyl alcohol. This is nothing but isopropyl chloride. Fine, we get this in here. Next, let's see another reaction of this kind. What happens when tertiary butyl alcohol, reacts with hydrochloric acid? Tertiary. This is going to be my tertiary carbon atom which has 3 butyl, so it will have 3 methyl groups attached to it. So this is your tertiary butyl alcohol reacts with hydrochloric acid. This reaction takes place at room temperature. You require concentrated hydrochloric acid in this case, right? Same dehydration reaction, water molecule comes out, H reacts with OH. The hydroxyl group is going to be substituted by chlorine group. So you will have CH3C, CH3, CH3, Cl. Right? This is tertiary butyl alcohol. This is tertiary butyl chloride. Right? So that's your reaction with hydrogen chloride. Now instead of hydrogen chloride, suppose if I do the reaction with hydrogen bromide, right? Let's see this. Same thing. I'm still using an alkyl halide. This is primarily a reaction with alkyl halide, right? What happens when ethyl alcohol reacts with HBr? Ethyl alcohol with HBr. Ethyl, 2 carbon atoms, CH3, CH2, alcohol reacts with hydrogen bromide. Now this reaction takes place in the presence of sodium bromide and sulfuric acid and heat, right? So the reaction takes place in the presence of sodium bromide and concentrated sulfuric acid, right? Same dehydration reaction, water molecule is out, Br group will substitute the hydroxyl group, so you will have CH3, CH2, Br. You have ethyl alcohol over here. Ethyl alcohol will give you ethyl bromide. Okay. Next, what happens when isopropyl alcohol with HBr, right? Propyl, 3 carbon atoms, iso, 1 carbon atom has to be in the branch, alcohol, OH, CH3, CH3, CH reacts with hydrogen bromide in the presence of sodium bromide and concentrated sulfuric acid. Heat the reaction. Dehydration takes place, water molecule comes out, that will give you CH3, CH, CH3, Br. This is isopropyl alcohol and this will give you isopropyl bromide. Fine, we get this thing here. Next, let's see another reaction of this kind. Say, what happens when tertiary butyl alcohol with HBr, hydrogen bromide, right? Tertiary butyl alcohol with hydrogen bromide. Tertiary butyl, 4 carbon atoms, right? That's my tertiary carbon atom. Tertiary butyl alcohol reacts with hydrogen bromide in the presence of sodium bromide and sulfuric acid. Heat, right? Dehydration, water is out. That leaves you with CH3C, CH3, CH3, Br. Right? This is tertiary butyl alcohol. This will give you tertiary butyl bromide. Finally, get this in here. So these are your reactions. I could do another reaction. Instead of taking hydrogen bromide, I could even try this reaction with hydrogen iodide. Suppose if I do the reaction with hydrogen iodide, what happens with ethyl alcohol reacts with hydrogen iodide. Ethyl alcohol with hydrogen iodide. Ethyl alcohol. Ethyl, 2 carbon atoms, alcohol reacts with hydrogen iodide. Boil the solution. You would still have the same kind of reaction. You would have dehydration taking place, where water molecule would come out and the hydroxyl group would be substituted by the iodine group. That means you would have CH3, CH2I. This is ethyl alcohol. This is ethyl iodide. Fine, do we get this in here? So this was your reaction with hydrogen halide. 3 types of hydrogen halides we saw. We saw hydrogen chloride, hydrogen bromide and hydrogen iodide. Next, let's see the next type of reaction. Let's see the reaction with phosphorus halide. Reaction with phosphorus halide. Right? Let's see reaction with phosphorus halide. What happens when ethyl alcohol reacts with phosphorus trichloride? Ethyl alcohol with phosphorus trichloride. Right? Ethyl alcohol, ethyl, CH3, CH2, alcohol, OH, phosphorus trichloride, PCl3. Right? Now in this case, you need to heat the reaction. You would require 3 molecules of phosphorus trichloride, 3 molecules of ethyl alcohol. Why? Because when you do the substitution, you will get H3PO3, hypophosphoric acid. H3, 3 H's, PO3, right? So the entire hydroxyl group is substituted. Once the hydroxyl group is substituted, you can then say that this will leave you with 3CH3CH2Cl, right? This is ethyl alcohol and this is ethyl chloride. Similarly, I could do my reaction with phosphorus pentachloride also. Suppose what happens when ethyl alcohol with phosphorus pentachloride, right? Ethyl alcohol, CH3 CH2OH, phosphorus pentachloride, right? Again, you need to heat the reaction. Now, here you would first get phosphorus pentachloride. one hydrogen will react with chlorine to give you hydrogen chloride, right? So out of the 5 chlorines, one is gone, right? Then you would have phosphorus reacting with oxygen, POCl3, phosphide chloride, right? So that means oxygen is out, phosphorus is out, hydrogen is out, oxygen is out, and 3 chlorines are gone. 4 chlorines are gone. That leaves me with 1 chlorine, CH3, CH2, Cl. This is ethyl alcohol, and this is ethyl chloride. Right? So that's my reaction with phosphorus halide. Right? Next, let's see the reaction with tenyl chloride. Reaction with tenyl chloride. Right? What happens when ethyl alcohol reacts with tenyl chloride? Ethyl alcohol with tenyl chloride. Right? Ethyl alcohol reacts with tenyl chloride. Now, ethyl alcohol. Ethyl, 2 carbon atoms, alcohol, OH. Right? Ethyl alcohol reacts with tenyl chloride, SOCl2. Right? You will be using a catalyst here, which is pyridine. Right? Now in this case, 1 hydrogen will react with chlorine to give you HCl, hydrogen chloride. You will get HCl in the form of gas, you will get hydrogen chloride gas. Now, the SO reacts with this oxygen to give you sulfur dioxide gas. So sulfur dioxide gas is out, hydrogen with 1 chlorine is out. That leaves you with 1 chlorine. So that will give you CH3, CH2, Cl. Right? This is ethyl alcohol. This is ethyl chloride. That's your reaction with tenyl chloride. Next, let's see dehydration of alcohol. So when we talk about dehydration of alcohol, there are 2 types of dehydration of alcohol. One is called as intramolecular dehydration. Right? One is called as intramolecular dehydration. Now, elimination of water molecule is dehydration. So, let's see how do we do intramolecular dehydration. Suppose, let's consider what happens when ethyl alcohol is treated with 95% sulfuric acid. Right? So when alcohols are heated with strong dehydrating agents, they lose a water molecule to form alkenes. Right? That is your dehydration reaction that we'll see. We'll first see with primary alcohols. Primary alcohols. What happens when ethyl alcohol with 95% sulfuric acid? What happens when ethyl alcohol reacts with 95% sulfuric acid? Ethyl alcohol, CH3, CH2OH reacts with 95% sulfuric acid. So in the presence of 95% sulfuric acid at 453 Kelvin, right? This reaction could also be done in the presence of aluminium oxide at 623 Kelvin or aluminium oxide at 623 Kelvin. Either way I could do the reaction. Either I use 95% sulfuric acid at 453 Kelvin or I use aluminium oxide at 623 Kelvin. Dehydration will take place. Water molecule out. Right? water molecule is out, that means you would have one H and one O bond. So that leaves you with CH2 double bond CH2, right? Ethyl alcohol gets converted to ethene. This is how you convert alcohols into alkenes, right? Let's see another reaction of this kind. Say what happens when propyl alcohol with 95% sulfuric acid, right? Propyl, CH3, CH2, CH2, propyl alcohol, 95% sulfuric acid at 453 Kelvin, or aluminium oxide at 623 Kelvin. Right? Now, in this case, same thing, you would have dehydration taking place, water molecule form. So in that case, you would have 1, 2, 3, CH3, CH, double bond, CH2. So 1, 2, 3, 4. Yeah, all the valencies are satisfied, right? So in which case you will get, this is propyl alcohol and this is propene. Fine, do we get this in here? Next, similarly, let us try to do with secondary alcohols. We did with primary alcohols. Let's try this reaction with secondary alcohols. What happens when sec butyl alcohol is treated with 60% sulfuric acid? Sec butyl alcohol with 60% sulfuric acid, right? Now I have sec butyl alcohol. Butyl, 4 carbon atoms, 1, 2, 3, 4. Sec means alcohol has to be attached to the second carbon atom. Draw your bonds. So this is going to be CH3, CH2, CH, CH3. Right? In the presence of 60% sulfuric acid. Right? Now, in the presence of 60% sulfuric acid, you will have, in this case, when you have higher alcohols or higher alkyl halides, which have to be converted into alkenes, you convert them into alkenes by using Sator's rule. The question is, if I remove alcohol, where do I put double bond? Should I put it here or should I put it here? Sator's rule says that you will put the hydrogen atom. From where will the hydrogen atom be removed? I want dehydration. I have one OH here. I need one more H for dehydration, for water molecule to be formed. Should I remove it from here or should I remove it from here? Because wherever I remove hydrogen atom from there, it's at that place that you will get double bond. So you have to remove hydrogen atom from the carbon atom carrying less number of hydrogen atoms. This carbon atom is carrying 3 atoms. This carbon atom is carrying 2 atoms. So you will remove hydrogen from here. That is what is Sator's rule. Right? So Sator's rule says that in case of higher alcohols, hydrogen atom from the adjacent carbon atom carrying less number of hydrogen atoms is preferentially removed. Fine, do we understand this? So this reaction I will do using Sator's rule. So in that case I will have dehydration, water molecule out, hydrogen I will remove from here using Sator's rule. So this will be CH3CH double bond CH, CH3, right? This is sec butyl alcohol and this is going to be 2-butene. Fine, do we get this thing here? Double bond, therefore ENE, double bond to the second carbon atom, therefore 2-butene. Fine, do we get this? Next, let's try this reaction with tertiary alcohols. Let's see the reaction with tertiary alcohols. What happens when tertiary butyl alcohol is heated with 20% sulfuric acid? Now, this was 60% sulfuric acid at 373 Kelvin. Or I could have done the previous reaction with aluminium oxide at 623 Kelvin. Now here, again I'm going to do a reaction of tertiary butyl alcohol with 20% sulfuric acid, right? Tertiary butyl, 4 carbon atoms, alcohol, right, with 20% sulfuric acid at 363 Kelvin, or I can use aluminium oxide at 623 Kelvin. Right? Same, you would have dehydration reaction, you will have water molecule coming out. Once water is out, since it's a symmetrical compound, from wherever I remove hydrogen, it will not make a difference. In the case of sec butyl alcohol, it was an asymmetrical compound. That is the reason why I had to apply Sator's rule. This is a symmetrical compound. From wherever I remove hydrogen, doesn't make a difference. So in that case, this will be CH3, CH3, CH2. Right? This is tertiary butyl alcohol. And this is going to be in that case butyl, because 4 carbon atom, double bond, therefore ENE, and you have methyl group in the branch, therefore iso. This is going to be isobutene. Fine, do we get this in here? So this is how you do intramolecular dehydration. Next, let us see intermolecular dehydration. The next type of dehydration that you have is intermolecular dehydration. Right? Now, in the case of intermolecular dehydration, you use concentrated sulfuric acid. Under this condition, you get one molecule of water is eliminated by using 2 molecules of alcohol. Right? For example, what happens when methyl alcohol is strongly heated with 90% sulfuric acid? Methyl alcohol with 90% sulfuric acid. Now, in the case of intermolecular dehydration, you will be using 2 molecules. So methyl alcohol, CH3OH, CH3OH. I am using 2 molecules of methyl alcohol strongly heated with concentrated sulfuric acid at 413 Kelvin. Right? HHO. Water molecule is formed here. That leaves you with CH3O, CH3. What you get here is ether. Right? Here you have methyl, so you have dimethyl ether. You will get dimethyl ether, and this is methyl alcohol. Fine, do we get this thing? Next, similarly, you can have a similar reaction with ethyl alcohol. Right? Here you have concentrated sulfuric acid, or I could have also used aluminium oxide as catalyst at 523 Kelvin. Right? Same way, I can have ethyl alcohol strongly heated with 90% sulfuric acid. Ethyl alcohol with 90% sulfuric acid. Right? Ethyl alcohol, C2H5OH, C2H5OH. I'm using 2 molecules. I'm going to use concentrated sulfuric acid at 413 Kelvin, or I will use aluminium oxide at 523 Kelvin. Right? Dehydration takes place, water molecule is out, HHO, right? That will give you C2H5O C2H5, right? This is ethyl alcohol and this is diethyl ether. Fine. That is how you do intermolecular dehydration. Next, let's move on to oxidation reaction. Fourth, fifth. Let's see oxidation reaction. It is generally the oxidation reaction that is used to distinguish between primary, secondary and tertiary alcohols. Right? Now, addition of oxygen or removal of hydrogen is called as oxidation reaction. Right? Now, let's see how do we do oxidation. The order of oxidation is primary has the highest order, then is secondary, then is tertiary. Right? Do we get this thing clear? So, let's see oxidation of primary alcohols. Now, what happens when, now in the case of primary alcohols get easily oxidized. They readily undergo oxidation to form corresponding aldehyde and then to form carboxylic acid having the same number of carbon atoms. So that's your distinguishing characteristics of oxidation of primary alcohols. They are easily oxidized. Second, they undergo oxidation to form oxidation to form aldehydes and then to carboxylic acid having same number of carbon atoms. Right? Now, for oxidation, it is oxidized, primary alcohols are oxidized by using potassium dichromate in dilute sulfuric acid. What happens when, say, ethyl alcohol with potassium dichromate K2Cr2O7 and dilute sulfuric acid. Right? Now, ethyl alcohol CH3CH2OH reacts with potassium dichromate K2Cr2O7 plus dilute sulfuric acid. When potassium dichromate reacts with dilute sulfuric acid, you get nascent oxygen. You will get nascent oxygen, right? So as we said, they easily undergo oxidation to form aldehydes. You would have a dehydration reaction taking place, H and O. So that will give you H and O. So in that case, you will get CH3CHO, acetaldehyde. This is ethyl alcohol. So in the first step of oxidation, they get converted into aldehydes. The aldehydes so form CH3CHO undergoes further oxidation to form carboxylic acid. How does it undergo oxidation? Because you still have potassium dichromate and dilute sulfuric acid to form carboxylic acid. So this will give you CH3COOH. So this is acetaldehyde undergoes oxidation to form acetic acid. Fine, do we get this thing here? So that's how you have oxidation of primary alcohols taking place. Next, you have oxidation of secondary alcohols. Now in the case of secondary alcohols undergo oxidation but less readily than um, in the case of primary alcohols, they oxidize first to form ketones and then they form acid, carboxylic acid, right? Like how they form aldehydes and acid. In the case of secondary alcohols get first converted into ketones and then they get converted into carboxylic acid. Now during this conversion, like in the case of primary alcohols, you have same number of carbon atoms. They get converted into carboxylic acid having one less carbon atom. So they undergo oxidation, right, but less readily. Second, undergo oxidation to form ketones, right? They undergo oxidation to form ketones, and on further oxidation and then to carboxylic acids. They further undergo oxidation to form carboxylic acid with less number of carbon atoms, having less carbon atoms. Let's see this. What happens when isopropyl alcohol is oxidized? Isopropyl alcohol is oxidized, right? Propyl, 3 carbon atoms. Iso, 1 carbon atom has to be in the branch. So CH3CH alcohol is oxidized, right? Now to oxidize this is oxidized by using potassium dichromate and dilute sulfuric acid. Potassium dichromate and dilute sulfuric acid, which will give me nascent oxygen, right? In which case you will have dehydration taking place. Water molecule comes out that leaves you with HO and one more H. So that means you would have the H coming out from here. So that means you will have CH3CCH3 double bond O, right? This was isopropyl alcohol. Undergoes oxidation to form acetone, right? Now the acetone so formed, CH3C double bond O CH3, undergoes further oxidation in the presence of chromium oxide. Prolonged heating. When you heat it for a long period of time with nascent oxygen, right, you will have one, dehydration takes place. You will have carbon dioxide gas evolved. So dehydration takes place, that means 2 hydrogens are out, right? 2 hydrogens are out and 3 oxygens are out of 5. So that leaves you with 2 oxygens. So that will give you CH3, 1 C is out, so COOH, acid. So this was acetone and this is acetic acid. Acetone has got 3 carbon atoms, whereas acetic acid has only 2 carbon atoms. So in the case of secondary alcohols, you get acid, but you get acid with less number of hydrogen, less number of carbon atoms. Next, let's see tertiary alcohols. Right? Now, tertiary alcohols undergo oxidation least readily. Undergo oxidation least readily. Right? Now, in this case, you have a multiple step reaction taking place here. They first get dehydrated to form alkenes, then they form ketones, and finally they form acids. Right? In the case of tertiary alcohols, they first get dehydrated to form alkene. Then the dehydrated product further undergoes oxidation to form ketone, having less number of carbon atoms. So here you would have less number of carbon atoms in ketones, and which on further oxidation forms carboxylic acid, having still less number of carbon atoms. So in the case of tertiary alcohols, the ketone will have less number of carbon atoms, and the acid that will be formed will also have less number of carbon atoms. So I can say that they undergo oxidation. They first undergo dehydration to form alkenes, right, which on oxidation give ketones having less carbon atoms, which on further oxidation give acid, carboxylic acid, having still less number of carbon atoms. Let's see a reaction, guys. What happens when tertiary butyl alcohol reacts with potassium dichromate and dilute sulfuric acid? Tertiary butyl alcohol is oxidized. Right? Tertiary butyl alcohol is oxidized. Carbon, tertiary, CH3, CH3, CH3. Alcohol, oxidized. It is oxidized by using potassium dichromate, Cr2O7, and dilute sulfuric acid. Right? Now, first thing you will have is they will undergo dehydration. They will undergo dehydration, that means they will lose a water molecule. As they lose a water molecule, HO, and they will lose one more H to form CH3, CH3, double bond CH2. So this is tertiary butyl alcohol, and this is going to be 4 carbon atom, therefore bute, double bond, therefore ENE, methyl group in the branch, therefore iso. So you get isobutylene. Fine, do we get this thing here? The isobutylene so form CH3C double bond CH2 CH3 undergoes oxidation in the presence of chromium potassium dichromate and dilute sulfuric acid. Right? It will undergo oxidation. This will give you nascent oxygen to form water plus carbon dioxide gas. Water means 2 hydrogens are gone. Carbon dioxide gas, that means carbon dioxide and water, that means 3 hydrogens are gone. So I have 1 hydrogen remaining with me. 2 hydrogens are gone, 1 carbon is gone, and 3 oxygens are gone. So that leaves you with CH3C, CH3, and double bond O. So here you are getting a ketone with 1 less carbon atom. So you have isobutylene getting converted to acetone. Right? Now the acetone so form CH3C, CH3, double bond O will react with chromium oxides for prolonged heating to get oxidized. Right? It will get oxidized to further form water, carbon dioxide gas, water, dehydration taking place, 2 hydrogens are out, carbon, 1 carbon is also out, right? That leaves you, and 3 hydrogens are out. So I have 2 hydrogens remaining with me. Sorry, 2 oxygens remaining with me. So this will give you CH3C. I have 2 oxygens remaining and 1 hydrogen remaining. Acid. So acetone will get converted into acetic acid. Right? This is how tertiary alcohols get oxidized. Fine, do we get this thing here? So if they ask you a question that distinguish between primary, secondary and tertiary alcohol, this is the answer that you have to write. From this chapter, this question is generally asked. Next, let's see what are the uses of alcohol. Where do we use alcohol? Right? It is used to prepare something known as wood spirit. Right? It is also used as a solvent in paints, varnishes. It is used in the preparation of formaldehydes, and it is used to make synthetic resins. Now these are methyl alcohol. Methyl alcohol is used to prepare wood spirit. It is used to prepare paints, varnishes, formaldehyde and synthetic resins. Ethyl alcohol. Ethyl alcohol is used to prepare grain alcohol, beer, right? It is used to prepare. It is used in the paint industry, and it is used in the preparation of multiple carbon compounds. It is also used for drinking purpose. So the alcohol that you consume, right, is ethyl alcohol, right? That finishes the uses of alcohol. We'll stop this here for the day. Thank you very much.